In our next example, we are told to verify a trigonometric identity, but in this particular case, we are looking at it and we might notice that the left side is complicated and the right side is also complicated. So what we're going to try to do is get rid of that fraction format on the right side. So in reality, not only are we verifying a trig identity here, we're actually verifying it by rationalizing the fraction on the right side. We're starting off with the right-hand side of the equation, and we're going to see what manipulation we could do to turn cosine x over 1 minus sine x into the left-hand side of the equation, so we could go ahead and say, hey, we verified it. Now, anytime you have a fraction like the one we're looking at here that we want to manipulate, you want to multiply top and bottom by the conjugate of the denominator, because that's what you could do to rationalize that entire expression. And whatever you multiply the denominator by, you have to multiply the numerator by that same thing. And as a result of that multiplication taking place, the numerator becomes cosine x plus cosine x times sine x, because we distribute that cosine in. And the denominator becomes 1 minus sine squared x. Now, at this point, we've probably seen the Pythagorean identity so many times that this already jumps out at you as the cosine squared of x. If it doesn't, we can go back and look at the Pythagorean identities and see which one is going to be applicable for that relationship. The denominator now became cosine squared x. So I'm going to rewrite this as cosine x plus cosine x times sine x all over cosine squared x. Now, my fraction has a numerator that has two separate terms, the cosine x and the cosine x sine x. So every time we have a situation like this, we can go ahead and split the fraction, split the numerator, and write it as two separate fractions over the common denominator that they're both going to share. So we are going to get cosine x over cosine squared x plus cosine x sine x over cosine squared x. Now, this cosine x cancels with one of the two cosine x's down below in the denominator. Same thing applies here. Cosine x here cancels with one of the cosine x's in the denominator there. So our fraction on the left has simplified to become 1 over cosine x, whereas the fraction in the right side has simplified to become sine x over cosine x. Now, at this point, we can see that the fraction on the left is the reciprocal of the secant. So we're just going to write down secant x in place of that fraction. And the fraction on the right is equal to tangent x. And again, we want to make sure that we are writing down our expression without fractions, because fractions are not considered simplest form. And whenever we want to verify an identity, we want to get rid of the fraction format. So we've done that now. And we could say that if we're comparing the answer we just got to the left-hand side of the equation that we started with, we can say that we actually successfully verified this identity as well. So that's it. But that's not quite it, because we could also take a look at the graphical approach to verifying identities like the one we're dealing with. So what we're dealing with here is the two functions that we have. The left-hand side of the equation is written here, and the right-hand side of that equation is written there. And what we're going to do is basically look at the graphs of each of these two possibilities. We're first going to look at this one, where the function is going to be the left side of that equation, and this is what the graph looks like. Now, we would say that the identity has been verified if the graph of this function is identical to the one we're seeing right here. So once we bring that up, if it overlapped, which it did, that means that this equation here is equal to this one here. So from the identity that we needed to verify, we could have graphically done the same thing by proving that the left side of the equation and the right side of the equation proved to have the same exact graph. So with that in mind, that's another method of verifying these trigonometric identities.